Good morning, everyone. My name is Russell McMurtrie. I'm here to teach you a thing or two about the organic molecule that's roughly 100 times stronger than steel. That is carbon nanotubes, of course. Let's get right into it. So, what exactly are carbon nanotubes? For starters, they're a simple organic molecule made out of carbon, obviously. Pretty similar to the organic molecule graphene, the stuff found on the tips of your pencils. But, spoiler, carbon nanotubes are 50,000 times smaller than the human hair, conduct electricity better than copper, also conduct heat, and are pretty gosh darn strong. They were discovered by two independent scientists, Sumio Lahima and Donald Bafut, in 1991 when experimenting with carbon and transition metal catalysts. However, carbon nanotubes are created artificially by humans, unlike many other forms of carbon such as graphite, charcoal, or diamonds. So how are carbon nanotubes made?
Ah, so this is where it all happens.
This is where the process begins.
And guess what? It's not even that difficult. Here's all you need. 1. A smooth surface with a thin layer of catalyst, a chemical that helps jumpstart the tubes. 2. A special mix of gases full of carbon atoms. And 3. This furnace, which, by the way, is really, really hot.
How much heat is it in there?
Right now it's around 800 Celsius.
That's about 1,500 degrees Fahrenheit.
Oh, I see the little black wafer in there. That's it?
Yeah.
That's nanotubes?
Yeah, exactly.
Wow, that is very cool. Baking away in there.
After just a few hours, the wafer is covered with a thick black fuzz.
So it looks just like a piece of black velvet. So if I were to really look in close to that, what would I see? What's it really look like under the microscope?
Well, we call this array of carbon nanotubes a nanotube forest. When we pull out one nanotube, that nanotube pulls out its neighbors, who pulls out other neighbors to self-assemble a yarn or a sheet.
Expert nano yarn spinner Kai Lewis gives me a hands-on lesson.
Would you like to try?
This I recognize. This is that.
First, we start with a forest on a wafer.
So you can just grab on to this little orange tab.
Okay.
Now don't make it too high of an angle and make
Okay.
sure it doesn't touch the edge. And just pull out,
Fast or slow?
whichever you feel comfortable with.
Oh, dude.
As I pull on this little tab, nanotubes are coming off the wafer, hooking other nanotubes and pulling them off the slide.
Try faster.
I'm so good at this.
And at too high of an angle, it will, as this is now, it'll start to break off from the forest.
It's like coming out forever.
Now, what allows carbon nanotubes to do all this amazing stuff is thanks to its unique structure. Similar to graphene, it consists of carbon and covalent bonds in a hexagonal pattern. However, unlike graphene, carbon nanotubes take the shape of a cylinder, or tube, as hinted in the name. Their unique tube structure is also the secret as to why electrons can flow through them with ease.
Like graphite, their delocalized electrons make them good conductors of heat and electricity. Plus, their unique structure makes them electron highways. Electrons can move along them extremely quickly at near ballistic speeds.
As expected, carbon nanotubes have tons of potential with all their unique properties. As of right now, two of the main uses for carbon nanotubes is structural reinforcement and nanotechnology, which makes sense because they're super small and pretty strong. So if carbon nanotubes are 100 times stronger than steel and also 1/6 the weight, why haven't they just replaced steel altogether? Unfortunately, due to their small size, carbon nanotubes can't replace steel. They can only reinforce it and help make it stronger. Now's the time in which I become desperate to reach the 7-minute requirement. So I'm going to take the time to teach you about the structure of a carbon nanotube. So now I will explain this model to you that took way too long to build and fell apart multiple times. Okay, as you see here, a carbon nanotube is composed of covalent bonds and carbon atoms. It's that simple. It's a lot similar to graphene, which is composed of covalent bonds and carbon atoms. Here I have drawn out the structure of graphene for you. You want to know the difference between graphene and carbon nanotubes? Watch. This is graphene. This is a carbon nanotube. The only difference is that carbon nanotubes are in a cylinder or tube shape. But that also makes them very much stronger. Carbon nanotubes are also becoming quite popular in the Tour de France, making bikes 20% lighter and stronger. I just wish they could have fixed my deflated tires right now.
Nanotubes can simply be thought of as single sheets of graphene rolled into a tube. Depending on how tubes are made or grown means changes to their structures. Different structure gives nanotubes different properties. This nanotube is a good conductor, while this isn't. Often nanotubes are capped with half a buckyball, a bit like this one. Nanotubes can be single-walled, double or multi-walled, giving them different properties again.